Good morning, boys and girls. Today we are going to see a mathematical expression of a wave. Now, here we want to derive mathematically the sine wave, and for that we are going to consider a transverse progressive wave. Now, when we are going to consider a transverse progressive wave, the particle position is important to us. So, in that situation, when I say that particle position is very important, it should be described by some factor that is called as the x, and displacement from the equilibrium position is described by y. Means exactly we say that xy plane we are going to consider, and along this one thing is to be noticed is that displacement and position, position is represented by x and displacement is represented by y. So such a sinusoidal wave can be written in the mathematical form like this. Here you will see that y of xt is equal to a sine kx minus omega t plus phi. Call this equation number 1. Now here this displacement depends upon the value of x and time t, and therefore it is given by equation a sine kx minus omega t plus phi. Now in that situation, here if you look into the equation 1, you will find that a is constant, k is constant, omega is constant, and phi is also constant. Now you are well familiar with these notations. So if we look, we find that y of xt is equal to displacement as a function of position x and time. Means you see here displacement, we are going to take y as a displacement along the y axis, and which is the function of position x and time t. So here we name a as the amplitude of the wave, because amplitude of the wave does the job of vibrating about its mean position, and when it gets vibrated, it goes to the maximum point, that we call it as a amplitude of the wave. Second is that at a particular instant, suppose now we have came to the equation only, sine wave equation, we have taken it. In terms of y, we say that it is nothing but displacement, and this displacement is said to be the function of x and time t. Now we will go for the second term. If we take this wave after the time t is equal to t0, means at an instant when we take the time t is equal to t0, we can write the same equation like this. Now here we have seen that y was the factor of x and t. Now I am replacing it by t0. So now we get a new equation, a sine kx minus omega t0 plus phi. Means equation number 1 is the same, only minor change is been made due to the substitution of t is equal to t0. Now here we say that this right hand side a sine kx plus constant, means we have taken that minus omega t0 plus phi is taken to be a constant value. Now next, If you look here, at time t is equal to t0, the shape of the wave as a function of x is a sine wave. We are all familiar about the sine wave. Means alternatively positive and negative cycle, half cycle comes following each other and it forms a sine wave. Now at that point, a fixed location now we are going to take, means location x, which is the displacement, we are going to take it as a x0. Now so here we are substituting x is equal to x0. So equation 1 becomes y of x0 t. We have taken the equation number 1, replacing y as a function of, instead of x we are taking x0 of t. Therefore the equation will be a sin kx0 minus omega t plus phi. Now here he says that if you take kx minus kx0 plus phi as constant, so equation becomes a sin constant minus omega t. Hence the displacement y at x is equal to x0 varies as a sine wave function. Here varies means what? It gets, when it tries to travel, it travels in the form of sine wave. So hence we say that the displacement at x is equal to x0 shows us a sine function. Next is that this meaning is been given that the particles of the medium through which the wave travels execute the simple harmonic motion around their equilibrium position. Now you know that what is mean by simple harmonic motion. So when example of the spring, when we take it, if we pull that spring, when it is in the normal condition and when we apply the force to the one end of the spring, then that spring gets displaced about the mean position and you find that it is making a simple harmonic motion. So this one tells us that the particle of the medium is executed in the simple harmonic motion around their mean position. Now next point is that for kx minus omega t plus phi to remain constant, x must increase in the positive direction as time t. Now when we want to make this term constant, what we are going to do? We must take into consideration that x must increase in the positive direction, means it should travel along the x-axis as the time t increases. Means now it is very simple that now our time has started, our wave has started to move. When it moves, we are saying that it is moving along the x-axis, and finally we conclude that the x must increase with the increase in time. Therefore the equation 1 represents a wave traveling along the positive x-axis. So it is, the meaning is clear cut that the equation is representing you a wave which is making a movement of traveling along the positive direction of x-axis. So this is how step by step we are going to explain the expression of a wave. Now next is, if you look similarly, a wave is traveling in the direction of negative x-axis is represented by. Now we have said earlier, just before, we have considered the wave is traveling in the positive direction of x-axis, but now we are going to consider the opposite side of traveling, that is along the negative x-axis, and therefore this equation is represented by y of xt is equal to a sin kx plus omega t plus phi. Now in the earlier case it was minus omega t, because in this condition plus is being changed to minus, minus is being changed to plus, and therefore we get kx plus omega t plus phi. This is called as the second equation. So when we get this second equation, this tells us that the wave is traveling in the direction of negative x axis. Now symbol has its own meaning as usual. First of all, y tells us the displacement of the particle functioning having the position x, and second time t. A is also known as the amplitude, k is called as the angular wave number, omega is called as the angular frequency of the wave, and finally the argument is that kx0 minus omega t plus phi is the argument of sinusoidal wave and is the phase of the particle at x at time t. So this is all about the, so here we have shown that when it is traveling along the positive direction of x axis, the wave equation was like this you have seen earlier. Here we have shown you kx minus omega t plus phi, but when we say that it is traveling along the negative x axis direction, we get this equation, and this was all about the explanation of your expression of wave.